Welcome at the Kistler webinar for weighted motion sensor and weighted motion site maintenance. My name is Petr Sevcik and I am a service engineer for road and traffic. In this presentation, I will be describing periodical assessment and maintenance procedures of weighted motion sites, which are based on Kistler Linux sensors. I will be more in detail speaking about weighted motion lifecycle to ensure Kistler is taking care of your weighted motion system from A to Z. I will also be speaking about the motivation towards the weighted motion sensor and the weighted motion site periodical maintenance. In 4 easy and manageable steps, I will describe recommended maintenance procedures. And last but not least, on the end of this webinar, I will show you some picture examples. Before I come to the core of this webinar, which is the sensor and site maintenance, I would briefly describe steps and services which precede successful sensor installation and weighted motion site commissioning. If you are interested in these services, there are of course other dedicated webinars relating to them. First of all, it is road structural analysis. This is the initial service which will help you to identify best location for a weighted motion site installation. Second step towards successful installation is the installation training and certification. During the on-site sensor installation, our service engineers will guide you through the installation and commissioning process. After sensor and system installation, there is another important process, which is a system calibration. Kistler may offer you on-site as well as remote calibration assistance. With warranty extension service, you can extend your sensor warranty up to 5 years totally. And periodic maintenance is integral part of whole life cycle of each weighted motion site. Goal of sensor maintenance is, I hope, obvious. We all want to achieve optimal performance of the WIM site, especially the highest possible system accuracy, as well as long lifetime of the sensors and safety of the road users and maintenance personnel. Quite often, we are receiving questions: what is the expected lifetime of Linux sensors? And our answer is the sensor lifetime is directly related to the road quality as well as maintenance of the site and sensors. It can be anything between, for example, 1 year in case of poor installation, up to more than 10 years in case of quality road and good maintenance. I would like to ensure you the requirements and procedures described in this presentation are practical and feasible to perform or managed by the provider or by the road owner. This slide is summarizing a bit what I already mentioned. The goal of periodical maintenance is to ensure performance and reliability of metrologically certified system. This is particularly important in case your system is working in direct enforcement environment. These sites are normally certified by metrology authorities to produce verified evidence data that can be used for direct penalization of offenders. You need to be sure your WIM system is 100% reliable. In second step, to ensure functionality of the equipment in and also next to the road. Also to decrease equipment downtime. This point is, I believe, quite self-explaining. To ensure safety of the road users and maintenance staff. For example, in extreme cases, especially in poor roads, the sensors may even be coming out of the road. Big potholes may be created around the slots for the sensors, which of course might present certain risk to the road users. And performing regular maintenance will, of course, lower your cost in long term. I would like to note sensor maintenance procedures described in this presentation are focusing only on existing sites with Linux sensors and shall not serve as guideline for selection of a new site. Selection of a new site is a task for our SRA service. In this presentation, I will be speaking about Linux type 9195G. This sensor is Kistler heritage since 1998. And Linux compact type 9196A, which is a relatively new yet very successful product. Both these sensors are virtually maintenance-free and have a long lifetime, which is normally determined only by quality of surrounding road surface, not by the sensors itself. There are 4 simple steps you should follow during the Weigh-in-Motion site lifecycle. They are visual inspection and manual procedures, checking of electrical parameters, seasonal maintenance of the road, and continuous monitoring. I will come more in detail to all these points later on in this presentation, and would like to ensure you that we, as Kistler, are ready to support you anytime, by the phone or email consultancy or directly on site. And if there is no other option, renewal of the installation is also the way. In following slides, I will be speaking about many features or issues. These features have certain limits and remedies. We also answer to the question, what are the points of relevance? What are the specs to be fulfilled? What are the procedures to test the specs? And how often to check? I would like to recommend you documenting all measured parameters and findings in a form of protocol, the way the changes can be monitored in the future. Please always observe all safety precautions as required by local standards to ensure increased safety at the site. Now we come to the topic of visual inspection and manual procedures. First of them is rutting. By the definition, a rut is a depression or groove worn into a road or path by the travel of wheels. Ruts can be formed by wear, or they can form through the deformation of the asphalt, concrete pavement, or subbase material. Ruts are more common in cold climate areas as the road surface is worn much faster by studded snow tires. Rutting has a direct impact on measurement accuracy. If you are installing new direct enforcement site, our recommendation is that the ruts shall never exceed 2 mm. However, this of course changes during the site lifetime and the ruts get bigger and bigger. To ensure reliable and accurate measurement, we therefore set the limit to 6 mm as a maximum. You should check the ruts leveled quarterly. The method is quite simple. Place a 3-meter certified rutting measurement beam across the road to measure rutting with a scaled wedge. Both wheel tracks are measured at 20 points within a 90-meter section. Spacing of measurement points is 1.5 to 2.5 meters in the sensor area and 5 meters on the outer part of the examined section. In some situations, there might be a difference between the sensor topcoat and the road surface. This shall always be limited to 1 mm max. If this difference is bigger, you need to grind the sensor topcoat so it is flush with the road again. Now we touch the point of topcoat wearing and or sensor protruding. In fact, these issues are very similar to ruts. They are more related to the quality of the pavement surface and or subbase material. In exceptional cases, due to the unstable construction of the road, the sensor might be sinking or even protruding below or above the road surface. The approximately 3 to 5 meter routing measurement beam, this of course depends on sensor spacing, is placed parallel to the road in the area extending from 40 centimeters before to 40 centimeters after the row of sensors at 5 different positions. See the picture. It is necessary to mark the positions or identifiers on the sensor and also support points on which the beam stands. The protocol must record whether the topcoat wears faster than surrounding road surface or the sensor protrudes above the surface level. If the LINAS sensors become more than 1 mm protruded, they can be reground so they are again flush with the road. However, in direct enforcement environment, the grinding shall always be limited to maximum 6 mm. If the LINAS sensor would wear more than 1 mm below the level of surrounding surface, it must be judged whether careful surrounding surface grinding would bring desired benefits. Repavement and new sensor installation shall be done if topcoat wear exceeds 2 mm, I mean the difference between the sensor topcoat and a road surface. Please note that topcoat undergrinding would result in lower weight readings, and similarly, if the sensor topcoat is not grinded enough, you would get higher readings. Another important procedure relates to checking the grout. Grout around the sensors must be firmly attached to the pavement as well as to the sensor. Due to the tensions inside of the road and also due to the different thermal characteristics of the sensor grout system, rather small cracks in the grout might appear within the time. The check shall be done quarterly, especially this is of course important after winter. The procedure is purely visual and subjective. So it is up to you to assess whether the grout damages you find are minor, medium, or even major. Minor damages are mainly aesthetical and present virtually no current risk to the sensor and/or road. Medium damages already present risk to the sensor or to the road. However, if acting quickly, they can be repaired and would not be a risk anymore. Major damages are of course problem. They are related, for example, to major grout and/or road crack, loose grout, small or big potholes, exposed cables, and so on. We recommend to repair such a major damages as soon as possible. Prompt repair would of course prolong longevity of the sensor. However, in some cases, this will be only compromising. Major damages might serve as an indicator that the lifetime of the sensor or the road is going to the end. After successful classification of the grout damage, you shall repair such an issue. Minor or small damages might be repaired by flexible, preferably two-component bitumen stuff. This is mainly to prevent water entering the defect. Bitumen is available in many forms. Probably the easiest to use are the cartridges. One example is Refug 2K by Vialit. Medium grout damages can be repaired using quick curing mortars. They usually also come in cartridges. You need to remove all loose material, make sure the spot is dry and refill it with the mortar afterwards. The mortar would cure quickly then. With a short period of time, you may reopen the lane for traffic. Good example is WIRT WIT VM250. Major grout damages and cracks require immediate action. They also would require more time to repair. Especially cases when the grout gets loose must be repaired within special attention. Loose grout must be removed, surrounding road surface must be cleaned, ideally by wire brushing. All loose debris must be blown away using compressed air. The slot would be backfilled by Kistler 1000A1 grout and reground after curing. Please note that the voids wider than 5 cm should not be backfilled by 1000A1. Repairs of bigger potholes must be consulted with the road owner or with a specialized road construction company, as they would require different repair technologies. After completing above-mentioned repairs, always make sure the pavement is flat in the vicinity of the sensors. Another important feature to check at least twice per year are the cracks. Cracks in the road represent a big risk to weight in motion side accuracy and of course also to the sensor lifetime. In direct enforcement environment, they should be avoided at all. However, cracks may appear within the time, so there is a need to evaluate them. Road crack remedies are not part of this webinar. They are usually being repaired by road professionals. However, during weight motion site inspection, cracks need to be checked visually and hand measured. They are also automatic systems though. Measured values and other findings need to be recorded using measurement protocol. Generally, an area of cracks with no or very few interconnecting cracks which are smaller than 6 mm in mean width are considered as a low crack severity. There are 5 major types of cracks. Each of them would require different remedy for improvement. As already mentioned, this is not in the scope of this webinar. However, I will briefly touch this point as it might influence maintenance decisions as well. Alligator cracking might be caused by excessive loading, weak surface or base or subgrade, thin surface or base or poor drainage. The remedy is full depth patch. Block cracking is usually caused by old and dried out mix which was placed too dry, or fine aggregate mix with low penetration asphalt. The remedy is any surface treatment or thin overlay. Edge cracks are usually caused by lack of lateral support, settlement of underlying material, shrinkage of drying out soil, weak base or subgrade layer, poor drainage, frost heave, or heavy traffic or vegetation along edge. The remedies are improvement of drainage, removal of vegetation close to the edge, or backfilling of the cracks. Longitudinal or linear crackings are usually caused by poorly constructed paving joint crack, shrinkage of the asphalt layer, daily temperature cycling, or cracks in the underlying layer that reflect up through the pavement. The remedies are improve drainage by removing the source that traps the water, sealing cracks or fill with asphalt emulsion. Reflection cracking are caused by differential movements between the asphalt and concrete layers and can be also caused by heavy traffic. The remedies are filling the cracks and sealing them. With this slide, we will leave the road and sensor installed in the road and will focus to the other side of the sensor, which are the electrical parameters The electrical parameters should be checked ideally before periodical calibration, so any irregularities would be discovered. Our Linux sensor troubleshooting guide, this is a separate document, compiles the measurements and repairs to be done on malfunctioning Kistler Linux sensor or as a part of periodical maintenance. This guide will help you evaluate whether the problem you face is truly related to the Linux sensor, predict remaining sensor lifetime, and evaluate whether the sensor can still be used or not. When raising a new quality issue, the results of measurements prescribed in this document must be recorded and reported to Kistler using the document Linux Sensor Failure Protocol. The document is containing list of required measurement devices, sensor measurements, grounding measurements, guide to taking photos of installed sensors, and also potential repairs. Please ask Kistler to share the Linux sensor troubleshooting guide as well as Linux sensor failure protocol with you. In this slide, we come to the point of continuous monitoring. Continuous monitoring of the weight motion system is always recommended. On daily basis, the user or provider should do the data analysis and checking for irregularities, perform statistical analysis in wider networks. Provider may be continuously monitoring vehicles passing the weight motion network, checking for deviations, and provide recommendation for calibration. Be working with the reference vehicles, statistical monitoring of the drifts. Be monitoring health of the system and be performing regular maintenance and cleaning of roadside equipment such as cabinet, PCs, cameras, and so on. Winter weather represents another challenge to the road and may influence the weight motion site performance. Snow and ice on top of the sensors may influence quality of the sensor signals, thus the system accuracy. If there is a snow and or ice coverage on the road, there can be shortcuts in the force flow and a damping of the signals. Snow and ice removal procedures on the weight motion site needs to be considered. Following are some general recommendations. Using of salt for melting of snow is considered as a best practice. The sensors are salt and water resistant. A snowplow used for snow removal shall not damage the sensors. This is ensured by proper sensor installation and or maintenance, where there is no height difference between sensor topcoat and road surface. Alternative use of any kind of hand instruments such as shovels and crowbars must be performed within a special care, as the asphalt is more breakable at low temperatures. Sensors shall not be cleaned using any kind of metal tool. Studded tires in general promote road surface abrasion, thus the wheel track rutting. In regions where studded tires are being used, the inspection of sensor topcoat needs to be more often. It is recommended to check the asphalt for cracks and other damages around the sensor as soon as the air temperature would stabilize above 0 degrees Celsius after winter. And if there is no other option, there is a time for Linux sensor reinstallation. In some cases, it is beneficial to replace Kistler Linux sensors with the new sensors. Before replacing the sensor, always ensure that the road surface complies with requirements of a weight motion station as specified in the Kistler white paper road properties. The sensors must not be installed unless all of these requirements are met. If the payment doesn't comply with the requirements, discontinuing of the installation and renovating of the payment is required. Or you can choose a different site as the conditions of the payment will highly influence the system accuracy. Anyway, linear sensor installation is finally quite easy. In the first step, you cut the sensor alongside as precise as possible. Do not widen the slot more than really needed. Nevertheless, all grout needs to cut off from the side. You may cut 10 or to 15 millimeters deeper than during the initial installation. If you don't know the exact depth, try cutting approximately 65 to 70 millimeter deep in case of G-type sensor. Insert flat or angled crowbar in the second step alongside and try to lift the sensor and break it from the bottom. After this, after successful removal of the sensor, a new sensor can be installed immediately in case the slot is completely dry. The empty slot should look like the slot in the picture. However, if there is a layer of old grout either on the sides or on the bottom of the slot, you need to remove the old grout completely. You may also need to redo the cutting of the sides. And now you can install the new sensors using standard installation procedure. On this and following slides, there are some examples of rather bad maintenance. The left picture is showing sensor installed in a quite weak surface. The sensor needs at least immediate grinding. Anyway, it is a bit too late for any kind of maintenance. It would be extremely difficult to repair the road surface surrounding the sensor. A right picture is showing sensors with some cracks on its side and exposed cable. These defects are caused by unnecessary long cuts, extra cuts, probably from the loops, and bad maintenance. You can see the slots were repaired by a different grout which didn't do the job properly. Left picture is showing quite old F-type sensor with disintegrated topcoat. Now it is already too late, but such a defect ought to be repaired quite easily. Right picture is referring to total sensor and site destruction. The sensor was installed in extremely cold and wet conditions. As a result, the grout didn't bond to the road surface properly. Sensor got loose in the slot, and when the vehicles were passing, the hammering effect destroyed even the road surface around. There is no other remedy than replacing the road surface completely. We are not speaking only about the sensors, but also about the cabinets and the systems. In the left picture, you can see the cabinet which originally was professional built, but after some years of continuous changes, there is a big mess. Components are even hanging in the air. As a result, the system is quite unreliable. In the right picture, you can see how simple explanation the problems sometimes have. The sensor wire wasn't inserted correctly into the clamp. And this is all. Don't forget to visit our web pages, download our new application, and contact us if anything is needed. Thank you for your attention and